All right, let's jump right in. We're going to break down a recent conversation that connects something as small as a single computer chip to this huge, interconnected vision for energy, transportation, and maybe even the future of humanity itself. It's a fascinating look at how all these seemingly separate pieces might actually be designed to fit together into one giant ecosystem.
So where does this whole thing kick off? Well, it starts with a pretty wild claim from an early Tesla investor. The idea is that the chip running Tesla's full self-driving software, which is one of the most advanced AIs operating out in the real world, is doing so with just mind-boggling efficiency.
And this is where it gets really interesting, right? When you put it side by side like this, you can see what they're talking about. To do one of the most complex things a human can do, drive a car, this little chip is using roughly the same amount of power as our own brain, which, handles everything we think and do. That level of efficiency, that's a huge deal.
So look, this is way more than just a cool piece of tech. It's actually a massive strategic advantage. I mean, think about it. When your AI doesn't need a giant battery or a constant link to a data center, you can put it in millions of cars or humanoid robots that have to operate out in the real world on their own.
Okay, so you've got this super efficient chip. Awesome. But that's just one piece of the puzzle, right? How does that actually stack up in the global race for AI supremacy? It's part of a much, much bigger and more competitive game.
Yeah, because this isn't just about who can build the smartest chatbot. The conversation we're breaking down suggests it's really a battle of efficiency, of cost, and of straight-up capital. Who can build and run this intelligence in the most effective way possible?
And check this out. This slide lays out the playing field perfectly. You've basically got this three-way race going on, and each player has a different edge. xAI is all about having the lowest cost per token or unit of data. Then you have Anthropic's Claude, which is super efficient. It gets the same result with half the data, making it great for things like coding. And then there's OpenAI, who had that big head start, but is reportedly burning through cash at a much higher rate.
But here's the thing. All of this, all these incredible AI models, these massive data centers, they are insanely power hungry. And that leads us to the next and maybe the most critical piece of this entire strategy. Who is going to provide all that electricity?
The source material floats this really interesting idea. What if the real long-term winner in the AI race isn't a software company at all? What if it's the company that controls the power needed to run everything?
And when we say they're going big to solve this energy problem, we mean colossal. The goal here is apparently to build the capacity to manufacture 100 gigawatts of solar every single year. I mean, that's utility-level ambition right there.
So the playbook here is actually pretty straightforward when you lay it out. Step 1, build an absolutely massive solar capacity. Step 2, use all that power for your own stuff, your AI data centers, your electric trucks. And then, step 3, you leverage that entire infrastructure and evolve into a global power company for everyone else.
All right, so you've got the power grid sorted. What's next? Well, where does all this incredibly efficient, powerfully backed AI actually, meet the real world?
And that brings us to the next big arena. This isn't about software in the cloud anymore. We're talking about the race to dominate physical AI. We're talking robotics and transportation.
So according to the source, this whole thing really comes down to a two-horse race. On one side, you've got Tesla's approach. Tightly integrated systems, hardware and software built together, and all of it learning from billions of miles of real-world driving data. And on the other side, China, whose core advantage is just immense, unmatched manufacturing volume and scale.
And this is where the conversation makes a really bold prediction, especially for heavy trucking. The argument is basically that the tech and efficiency gap, from the batteries to the software, is just so huge that it could lead to almost complete market domination. 90%? That's a huge number. Okay, so let's say the goal is to dominate physical AI and energy on Earth. Where do you go from there? What's next? Well, the conversation expands one last time, and it looks toward the final frontiers.
Right, and this is where the whole vision just goes to another level. We're talking beyond ambitious. It's not just about cars and power grids anymore. It's about looking up to space for basically unlimited energy, and looking inward to the human mind for the next evolutionary step. And that energy plan, it doesn't stop at the edge of the atmosphere. The long-term vision here is to make all of Earth's current power generation, that's about 3.4 terawatts, look tiny by comparison. We're talking about massive solar farms in space, potentially generating tens or even hundreds of terawatts of power.
And then there's the final piece of this interconnected puzzle, Neuralink.
It's presented as this brain-computer interface that starts by aiming to solve really serious medical problems, like paralysis and blindness. But the ultimate stated goal? To literally merge human consciousness with artificial intelligence.
So let's step back and connect all these dots, right? You have one hyper-efficient chip powering a dominant AI, which is fueled by a private global energy grid deployed in millions of physical robots, and then ultimately linked directly into our brains. It's this incredible vision of one massive, interconnected ecosystem. And it leaves you with a huge question. What happens when one ecosystem powers it all? That's our breakdown for today.